Hello everyone, so now we are going to be graphing the transformation of the parent function that is given in the following graph. It might help to label the coordinates on this parent function here. So my first coordinate is at negative 4, 1. My next point is at negative 1, 1. My next point is at the point 1, 3. My next point is at 2, negative 3. And my next point is at 4, 0. So in number 1, when I have a plus 3 on the outside, what this is doing is, at first I need to describe what happened. Well, the description should be that you're translating this up 3 units. So what we are really going to do is we're really going to add 3 to all of my y values. So the point negative 4, 1, if I add 3 to the y value, I get the point negative 4, 4. So that's where that new point is. The point negative 1, 1, if I add 3 to that, I get the point negative 1, 4. The point 1, 3, if I add 3 to the y value of that, I get 1, 6. To the point 2, negative 3, if I add 3 to the y value there, I get 2, 0. And for the point 4, 0, if I add 3 to the y value there, I get the point 4, 3. So this is what your new graph looks like when you translated it up 3 units. Or what we could have done is we could just have moved all of these points up 3 units to arrive at our new graph. All right, so for number 2, if I'm subtracting 2 on the outside, this means that this is a translation down 2 units. So I can either, from my original graph, just move each point down 2 units, or if I'm moving it down 2 units, I'm really subtracting 2 units from the y values of each of these points. So if I do negative 4, 1, that point, and I subtract 2 from the y value, I now have the point negative 4, negative 1. If I subtract 2 from the y value of the point negative 1, 1, I now have the point negative 1, negative 1. If I subtract 2 from the y value of the point 1, 3, I'm now at the point 1, 1. If I subtract 2 from the y value of the point 2, negative 3, I'm now at the point 2, negative 5. And then lastly, if I subtract 2 from the y value of the point 4, 0, I am now at the point 4, negative 2. And so this is what your graph would look like after the translation down 2 units. All right, number 3. If you're adding 1 on the inside of your parentheses, basically what you're doing is you're doing a horizontal translation, but it's the opposite of what it looks like. We're going over 1 to the left, which essentially you can either just move this whole graph 1 unit to the left, or a horizontal translation of 1 unit to the left would be subtracting 1 from each of your x values in this function. So the point negative 4, 1, if I subtract 1 from my x value, I'm now at the point negative 5, 1. The point negative 1, 1, if I subtract 1 from the x value, I'm now at the point negative 2, 1. And the point 1, 3, if I subtract 1 from the x value, I'm now at the point 0, 3. From the point 2, negative 3, if I subtract 1 from the x value, I'm now at the point 1, negative 3. And then from the point 4, 0, if I subtract 1 from x, I'm now at the point 3, 0. So this is what your new graph looks like. Notice in each one of these graphs, the shape of your graph did not change. There was no stretch. There was no compression. It was just simply sliding the graph to a new location on the graph. However, in number 4, we actually are dealing with, since the number that's is on the outside of f of x, then this is actually a vertical stretch by a factor of 2. So what you could expect is you can expect to stretch this graph up by a factor of 2. And when you have a vertical stretch by a factor of 2, technically, to find the new points, you leave your x value alone, but you multiply your y value by 2. So for each of these points, I'm going to leave my x value alone, but I'm going to multiply my y value by 2. So a 1 times a 2 is a 2. So my first point would be at the point -4, 2. Now with my next point, I'm going to multiply my y value by 2. So a 1 times a 2 is a 2. So my next point is at -1, 2. I'm keeping my x value the same. The next point, I'm going to multiply my x value by 3. My y value by 2. A 3 times a 2 is a 6. So now I have the point 1, 6. My next point, I'm going to multiply -3 by 2 to get a -6. So now I have the point 2, -6. And then lastly, my last point, I'm going to multiply my y value of 0 by 2, which is just a 0. So I have the point 4, 0. That point does not move. And this, when I sketch my graph, this is what my new graph looks like, which makes sense because I did a vertical stretch. So actually the lengths between the segments vertically got a lot longer. I stretched it up. Now in number 5, the negative's on the outside. So what that means is that this is a reflection over the x-axis, which means that the only points that are changing are my y values of my points. And I wind up with x and then the opposite of my y value. So on the point -4, 1, my original y value is 1. So on my new point, my new y value is going to be -1. So I have the point -4, -1. On my next point, my y value is going to change to a -1. So I have a -1, -1. On my next point, 1, 3, my y value changes to a -3. So I have the point 1, -3. And then on my next point, 2, -3, my y value is now going to be +3. So I have the point 2, +3. 4, 0 is on the x-axis, so that does not move, it just stays where it's at. So this is what your new graph looks like. It's just the original graph flipped upside down. All right. So now in my next graph here, I have my reflection in my y-axis, which means that my x value is going to become negative, and my y value is going to stay the same. But then I also have, this is a horizontal compression. We got to be careful. It is a horizontal compression. And that is, my k value would be 1/3, but we're going to describe it as first a reflection over the y-axis and then a horizontal compression by a factor of 3. Now, since this is a compression, then what that means is that my k value is 3, but I'm really multiplying all my x values by the reciprocal of 3, which is a 1/3. So I'm going to multiply all my x values by a -1/3 to account for the negative accounts for the reflection over the y-axis, whereas the 1/3 accounts for the horizontal compression by a factor of 3. Remember, when your k in your equation is greater than 1, that means that that's a compression. And so we multiply our x values by the reciprocal of our k value. All right, so my x value of -4 being multiplied by a -1/3 is going to become a +4/3. And then my y value stays the same. So +4/3 and a y value of 1 puts me at the point right here. I'm just going to estimate the points. Next point, my x value of -1 times my -1/3 gives me a +1/3. Oh, I apologize. I did a -4/3 on that first one. So that's a +4/3 and a 1. And my next point would be at a +1/3, 1. So about right here. Now my next point, my x value is 1, so a 1 times a -1/3 would put me at -1/3, 3. My y value stays the same. My next point is at 2, -3, so multiplying my x value of 2 times a -1/3, I wind up with a -2/3, and then -3, which is about right here. And then lastly, my x value of 4 multiplied by a -1/3 is a -4/3, and then my y value stays the same, which is 0. So this is what my new graph looks like, which is a horizontal compression, and that's exactly what happened here. My graph got smushed together horizontally. All right, so I am going to have to continue the next part of the level 4 in the next video. So please pay attention to the next video for the rest of this lesson.